All right, and if you're connected in remotely, if you could mute your microphone unless you need to say something, please. It'll keep the background chatter down. I've sent you a bunch of emails. This is 530-707, Robot Systems Programming. I'm going to be screen capturing the first couple of classes so that if you want to review anything that we covered in class. The purpose of this class is to basically have a course orientation on what the structure of the course is. I put up the course webpage yesterday, and hopefully you've looked at it. And I'd like to go over it briefly. Most of it is self-explanatory. Basically, we're going to learn how to use ROS to program robots and to rapidly prototype fairly complex robot software systems. And the course is going to consist of two pieces, the piece before spring break and after spring break. Before spring break, there are 7 programmed assignments, the last one that's due immediately after spring break. And then there's a 5-week project, an independent project, where you can work in groups of ideally 2 or 3 students, where you'll have your own robot and you're going to possibly modify its hardware and write new software for it, and do a project where the robot does something useful. The course description is right here, and pretty much what I said. I'm the instructor. We've got 3 fantastic TAs, and I think they're all here. Han Shi, right here, and Chia Hung Lin, right here, and Gabe Barabin, right here. And they all did pretty interesting projects last year, and I won't show them today, but we'll show you some video of each of their projects. They're both pretty they're all 3 of them were pretty impressive last year. The class meetings are Tuesday, Thursday. Starting next week, most of the Tuesday class is going to be a lecture where I'm going to basically be reviewing what the module we're doing that week. And most of Thursdays will be a clinic where you can bring your computer to class and you can work on stuff, and I'll be there and you can ask questions. 2 years ago, I rebuilt this course, and when the course was really small, we had a few robots and we all shared them. When the course got larger, that didn't work anymore. And so I'm going to give you all one of these things, a self-balancing robot that runs Linux and has Wi-Fi and Bluetooth. We'll get more into the details of the robot shortly. And I'm hoping the people that are online on the Hangouts can hear me. If not, there's not much I can do about it. For resources, there's no assigned textbook, but there are several references here that I list, most of which are available free online. They're pretty good. For the ones that are more than 3 years old or so, you have to do a little translation because they'll be working with an earlier version of ROS, and so some things won't be quite right. Prerequisites, RDKDC and algorithms. You can be taking one of those concurrently with this, but you can't be taking both of them concurrently. You need to be an intermediate C++ programmer, and you need to have your own Linux machine running Ubuntu 16.04. And I'm sticking with 16.04 for 2 reasons. One, it stays current with the version that they're using in RDKDC and algorithms. 3 reasons. 2, it's stable, and 3, the tutorials aren't broken. The 1804 tutorials, some of them are broken. And here I give some advice on setting up your PC. I personally despise the Unity desktop shown there. I much prefer the Xubuntu desktop, but your mileage may vary. I have my own Wi-Fi station that I'm bringing to class, and the Turtlebot network is there. So if you want to hook into the Turtlebot network, the SSID is Turtlebot 2.4 gigahertz or 5 gigahertz, and the password is Turtlebot lowercase 707, one word. And if you set up ROS, then you can graze upon the topics and things like that I'm publishing. For at least the first few classes, I'm going to screen capture the lectures, and I'm doing that now, and I'll upload them within a day or so of the course. We have a teaching lab in Wyman 170. Your JHEAD IDs are percolating through the system, so that soon they'll be in the JCard. You'll have JCard access, and you'll also have login access for the PCs that are in Wyman 170, so if you want to use those. I was over there, it's a little trashed, we're going to try to clean it up, but remember the campsite rule in Wyman 170, always leave the campsite cleaner than you found it. The way we're going to hand in assignments is we're going to be using a repository called getteach.lcsr.jhu.edu. You've probably used it before. There was some problem with logins that I think that IT has resolved today. So the TAs were able to log in successfly, and if one or two of you would try to log in and tell me whether you can get in, I'd be grateful. If you can't, let me know. If you do, let me know. I'm going to ask you to push each assignment to a repository with a very specific name, and don't deviate from that name, and then share it with the 3 TAs and me, and we're going to run a Python script to pull those down each week. And so using the specific name for your repository really matters, otherwise we won't get it. So the course grade is going to be based upon class participation. Do show up for class. I show up for class. I think it's important. I expect you to. The weekly assignments will be less than half of the course grade, and the final project will be about the same. And the weekly assignments, you need to push your Git repo for the first 7 weeks by 4:30 p.m. Tuesday. And if you have a problem, if you're sick, if your friend just dumped you and it's a bad day, contact me before the deadline if you need an extension. I'm pretty generous, but don't contact me after the deadline. And there's no credit for things that are pushed at 4:31 p.m. Don't get 0 credit. And the lowest of the 7 assignments, the lowest score is dropped. There will be an independent project demonstration sometime on Monday, Tuesday, depending on how many, maybe 1 day, maybe 2 days. This is reading period. The demo schedule I'll update, and then we'll have the finale for the course is in the time where we would have a final exam. If there were a final exam, we'll have a poster session, and I'll buy pizza, and that'll be I think on Saturday, May 11th. But the registrar hasn't published the exam schedule yet, so that is subject to change. Any questions about the course? Okay, so on the course webpage, there's a section down here called, down here at the bottom, called Ethics. And I'd like you to read this. And basically, you want to hand in code that you wrote, and some students got in trouble last semester, and I had to call them up on ethics violations. It was more than a few students. It surprised me, because partway into the course, about a third way into the course, we got some assignments in where, gee, that source code looked quite like the code that I demoed in class, including variable names, unused variables with odd names, weird comments that I put in my code. They all were reproduced in more than one student's code that they handed in. So that's bad. Now, I want you to be, in many of these assignments, the coding, you go through tutorials and your code is going to look a lot like the tutorial code. That's okay. Just comment in the code, I'm basing this on such and such tutorial, here's the URL. Just like when you're writing a paper, if you cite the source of the information that you got and you indicate that it's a quote or a paraphrase, then it's not plagiarism. The worst thing will happen is if you cite the source, if you say, I'm handing this in, I got the entire program off the web, here's the URL. So you did no work, well, that might mean you get 0 credit, but it's not an ethics violation, right? I want 0 ethics violations. So if you use a snippet of code from somewhere, don't just go around and change the variable names to XX and XXX. Just acknowledge your sources, and it's not an ethics violation, all right? So disclose outside sources.
Should we do that like in the comments?
I'm sorry?
Should we do that in the comments?
Yeah, in the comments. Yeah, code your, comment your code, and that's why, like, one of the great things about like MATLAB, like if you if you look at most of the MATLAB algorithms that are built into MATLAB, and you actually look at the source code, they'll actually cite the paper where which reported that algorithm for the first time. And so that's a good example of scholarly programming. Any other questions? Do you guys want to add anything for the class? Things that you wished you knew last year at this time? About the final project? Oh, yep. So Hanshi has a good comment. Students, at the end of last year, when I asked for comments and suggestions on how to improve the course, everybody thought that they should start thinking about their project earlier in the semester. And so I'm going to try to structure that into the next couple of weeks. And I'm thinking that I will ask for a preliminary project proposal like in 2 or 3 weeks. And it doesn't have to be what you eventually do, but I want you to start thinking about this now. Anshi is exactly right. And if I can juggle the course material, I'm going to try to compress the assignments so that I save a week on the front end of the structured assignments, and you get an extra week to do the project. I'm not sure if I can do that, but I'll try to work that out. Any other suggestions? Yes. Not more than 4. My sense is that somewhere around 4, you get the people in the group. There are those who are just like being carried along in the carried along in the convoy, right, by the section of the other students moving very quickly. And 2 or 3 is probably the ideal number. I want to come up with a rubric so that I can better evaluate the contribution of the different students in the project. And I'm not exactly sure what that'll be, but I'll figure something out. Any other questions? Okay, well, we're on short time here. Let's see if there's... I'll reiterate the ethics thing a few more times. Class schedules, office hours. Office hours will start on Friday at 12 to 1 p.m. Anshi, is that okay? And I reserved 111 Hackerman. And we may modify these and add an additional one if need be. And the idea here is that you'll hand in things on Tuesday, so probably Wednesday may be a dead day. On Thursdays, we have essentially office hours in class most weeks, and there'll be an office hour on Friday, and then on Monday and Tuesday, and your assignments will be due on Tuesday. So we've tried to structure those to work with that. The robot that we're using is called an EduMIP, and it's developed by my friend Tom Bewley at UCSD, and if you follow these links, you'll find out more about it. And there's a web page here that I've made, which is how to put ROS on the EduMIP mobile robot, and so you'll be using this web page for this. We've got a bunch of these things that are pre-assembled, and those of you who want to assemble your own, we can give you the kit of motors and pieces, and you can put it together yourself. And so let's let me go to slides. We'll see how much we can get in of a brief overview of ROS in the last 10 minutes. Probably won't finish this, and we'll finish this So I'm going to give you an overview of the robot operating system, and we want to talk about the core components, the ecosystem, and some of the features of ROS. And on Thursday, we won't finish this today, but we'll finish it on Thursday. And then also on Thursday, we'll do a brief review of the assignment for this week. Sorry, let me go back here. So the structure of each week, I meant to mention this, the structure of each week's assignment is shown here in the table of contents. Module 1, I'll do the robots of the week on Thursday, and I'll list the topics of the week's module, assigned reading, and specifically what you need to do. You need to do a set of tutorials, and you need to hand in an assignment. And so each week is going to have that structure. And so if we hop to that, we'll see week 1. You need to get Linux and ROS installed if you haven't done it already. We're going to do an overview of this stuff. We've done that. And then I'm going to give you a background of the robot software frameworks and ROS core. I want you to do this reading. I want you to read these web pages. You can skim some of them, like the style guide, but be aware that it's there. If you're not familiar with Git, do these tutorials. You'll need to know that much about Git in order to push your assignment. This is a cheat sheet for ROS commands. I want you to read this documentation, and here are the assignments. I want you to have installed Ubuntu and install ROS, and then complete the tutorials that are begun on this web page. And I've listed the tutorials that I want you to actually do. They're named here. So you're going to go from navigating the ROS file system down to writing a simple publisher and subscriber in C++. And then and in the assignment, I give you very specific language on what to do. We'll review this on Thursday, and how to push it to the repository. Okay. So some of the courses that I've created here at Hopkins related to robotics include electronics and instrumentation, robot sensors and actuators, RDKDC, what we now call RDKDC, and most recently this course, robot systems programming. And if you want to follow along with this on your laptop, I sent out a link to where to download the PDF, so you can click on these links and jump to them. So the core components of ROS, so what is ROS? It's a publish-subscribe messaging system, so you can have multiple programs communicating to each other in a civilized fashion, and you can federate information. There are good introspection tools for passing messages and information between processes. ROS spans multiple machines and multiple operating systems, so the older versions of ROS are pretty much only supported on Linux. ROS 2 is going to be supported under Linux, Windows, and Mac OS, although exactly why you would want to do the latter two is a little unclear to me. But it provides a standard system for communicating information between different machines. The core of the ROS system in ROS 1, ROS 2 is under beta release. It's not going to be really solid for another year or so. Is a message passing system that uses what's called a master. So you run one ROS master or one ROS core, and all the different ROS nodes that are fired up on this machine or some other machine can communicate to the ROS core, and it's the clearinghouse of who's publishing what. So if I'm starting things out here, robot falls down. So I've got a couple windows open here, and ROS core I'm going to open in this window. That's running on my laptop, and it's advertising itself over the local network, over a socket. And in this window, I'm logged into the EduMIP over there. It's running Linux, and I'm just SSH'd into it. It's connected via Wi-Fi. And so I'm back in my laptop here, and I can just SSH -X Ubuntu at 192.168.10.102. I'm connecting into that Linux machine. I'm logged in, and I'm going to type a cryptic ROS command that runs the balancing program. And then I can tip the robot up, and it'll bounce. And I can run another program here locally on my PC which will read the joystick and publish some information. RQT graph. So RQT graph is a utility that you'll be using in the first week, and I'm not sure if you used RQT graph in algorithms or RDKDC. This shows that there's a process called JoyNode publishing a topic called Joy that's being published on this machine, and that topic is being subscribed to by a program running on the EduMIP, and the EduMIP is it's being read by ROS JoyNode. It's publishing EduMIP command, and that's being read by the EduMIP over there. And when I move a joystick, I can turn, go back and forth. Let's see, that would be forward. That would be backwards. So each of these little circles is a process that's the right-hand circle is running on the EduMIP. The two left-hand circles are running on my PC. This is an example of the simplest ROS program, and you need to include ROS.h. You need to call ROS init and ROS start, and then you're off to the races. Then you can call any ROS command. And so this is the world's simplest ROS program, and if we weren't doing a short class, I would compile and run it for you, but suffice to say that it runs. And ROS's message passing system is, I can illustrate here, is based on the notion of topics. So there are named data streams, and these are the data streams that are running right now. And if I say ROS topic echo joy, nothing happens until I move my joystick, and then I can see joystick messages coming out. And so those are these messages right here. And there's a C++ program that I wrote that's publishing EduMIP command messages, which are twists. So ROS topic echo allows me to introspect on the messages, and when I move my joystick forward and backward, then you can see that the EduMIP command messages of the type twist that you covered in RDKDC. So ROS normally communicates messages over TCP, and it also supports UDP for unreliable communication. And there are other message passing systems. MPI, LCM, Moose are other ones that are used in robotics. It turns out that ROS has become much more successful. This is a diagram sort of trying to illustrate what's going on in ROS with the different client nodes running here, ROS master arbitrating and providing a table of contents for messages that are available. And in the first assignment in the tutorials, you'll run RQT graph, RQT, you'll use the ROS topic and ROS message command to introspect over topics and messages. Unlike LCM and other message passing systems, ROS comes pre-built with a bunch of standard messages that are useful for robotics. So transformations, twists, sensor messages, geometry messages, navigation messages, image messages, things like that. There's a whole bunch of them that are predefined. So if everybody is together using the same messages, then, for example, a message that encodes an image in an image stream, if we all use the same message, then when I write a driver for my camera and you write a driver for your camera, you'll both be publishing the same message type, and the downstream processing can be nearly identical. So these are common messages, and if you click on this link, you can introspect into the message comments. Another thing that you need to do when you run a robot program is you need to initialize parameters for the robot. So For example, in a mobile robot, you might want to initialize, what time zone you're in and the latitude and longitude of a local XY coordinate system if you're using a local XY system. You might want to initialize parameters on how many cameras you have and where they're located, and how many different kinds of sensors that you have, and specify them. And so the ROS core has a parameter server built into, and you'll do an exercise where you experiment with that this week. And ROS also supports recording and playback of messages. And I'll try to demonstrate that on Thursday. I don't have time enough to do that now. And then there's this thing that you experiment with a little bit called services. Publishing a ROS message, a node can advertise a message by declaring a topic, and then anytime the node wants to publish a new image from a camera, it calls a publish method. And any node that's subscribed to that topic will get a copy of the message, if it's possible. And but it's a one-way communication. And when you publish on a topic, you don't know whether anybody's subscribing or not. Services are like a remote procedure call, where you send a service request over to another node, and then when the service call completes, they've sent a response. And so it's a way of doing a rendezvous. Comment on ROS security. In ROS 1, as we call it, there is no security, so the only security is basically the security of your subnet, so you need to keep your subnet isolated. In ROS 2, there's a whole bunch of built-in security based upon DDM. And we can break here. Some people get intimidated by dipping their toe into the ROS ecosystem, and it's like, it's so big! Well, if all you want to do is federate messages and communicate between processes, you can stop right here. It's a very effective message passing system. You don't need to use any of the other tools like RViz or Gazebo or things like that. You'd be foolish not to, but you can use ROS on the bare bones with just the things that you've covered really in the first 3 or so weeks of this course. However, and we'll pick it up here on Thursday. There are some very powerful tools for introspection and simulation that once you use them, you'll never want to go back. You'll save a lot of time. So the university has declared that we have a short class today. My watch just told me that it was 5 o'clock a minute and a half ago, so any questions? All right. Sorry about the short class. I'll see you on Thursday. Okay, again, that's it. I'm going to hang up here. If you have any questions, then just shoot me some email. Okay? See you later. Hang on a second.